Right, here we are. So we are absolute beginners, not full-blown electronics nerds just yet. Haven't even worked on the nerdy voice yet. So, but what are all these components we keep hearing about? Well, this is the absolute beginnings of electronics. But we have to start somewhere, obviously. So, this is partly about jargon busting as well, really. Anyway, so you'd be hard pushed to find any electronics circuit that doesn't have one or more of these items in them somewhere. So let's look into them a little bit more detail and try and help us understand what they're for. Okay, here we have a couple of examples of some resistors, small ones and big ones. As you can see, they have two legs or terminals, and they have various different markings depending on what type of resistor they are. Resistance is basically a measure of the opposition to the flow of current in a resistor. The larger the resistor's resistance, the greater the barrier against the flow of current. So think of it like water flowing through a hose pipe, which represents the current. A restriction of the pipe that makes the water difficult to flow is like a resistor. Resistors are said to be passive electrical elements, meaning they can't provide energy to a circuit. Instead, they absorb energy and release it as heat when current flows through them. Resistors in electrical circuits, or electronic circuits, limit current flow and create voltage drops. They come in various resistance values ranging from fractions of an ohm to millions of ohms. But what do? So in electrical and electronic circuit, resistors are used to limit and regulate current flow. They divide voltages and adjust signal levels. For example, if you can imagine an LED light, the current flow from a power source may be too large and would destroy it. A resistor will lower the current and act as protection for the diode. So there we have it. That's about all you need to know to get you started, really. Right, here we have some capacitors. So these are the second of our three basic components we're talking about. They are a device that holds an electrical charge for a particular amount of time. This is one fundamental reason that you need to be careful opening up electronic devices. They can still hold a charge a long time after they've been switched off, which could be lethal if it's a high voltage capacitor. So basically, when a voltage is applied across it, it will store this charge and then release it back into the circuit. The basic construction is made from two parallel plates that form your terminals, and these are separated by an insulator known as a dielectric. The charge in a capacitor happens gradually, and the same for when it discharges. This charge is said to appear exponentially. The capacitor's ability to hold charge is called capacitance and is measured in farads. You may recognize that name. In some ways, capacitor is basically like a battery, except that the battery holds its charge for a much shorter time. Typical applications for a capacitor include blocking direct current, removing ripples, filtering, and in applications where a charge is released quickly, such as in a flash on a camera. So there we go, that's the basics. Okay, we have a few different sizes and shapes here. There we go. Right, so here we have our third and final component. So these are called inductors. In its most basic form, as you can see here, this is just a coil of wire basically, but that's what they are essentially. So this is another component that stores energy in some form. At its most basic level, as I show you, it's just a coil of wire. Some of these are constructed with a magnetic core as well. So basically when these are energized, they will generate a magnetic field. This makes for some interesting applications. An inductor will resist sudden changes in current. So say you put this in line with an LED, it will mean that the LED will energize gradually rather than straight away. Of course, the opposite will be true when the power is removed. The current will reduce to zero slowly. In doing this, there will be a sudden change in voltage. The current can flow in the air for a fraction of a second until the magnetic field breaks down. The effect of a coil in the wire increases the magnetic field further. As the current changes, the magnetic field will also change. Inductors are common in power supplies to build a buck or boost converter. They are also used in radio tuning circuits and filters. If you come across an electromagnet, it is essentially an inductor. You'll find them almost anything that moves from electricity, like relays, motors, solenoids, speakers and more. Finally, the effect is called inductance, and that is measured in henries. So there we go, that's a basic overview of these common components, and hope you learned something. If you want to know any more or you have any questions, drop them in the comments below, and we'll see you soon. Cheers.